And example number 2 says solve. So what we need to do is we need to make one side equal to 0. And with a quadratic equation, I guess before I make one side equal to 0, I'm going to distribute that 3. And you can make either side equal to 0. Often it's easier if you make the left hand equal to 0, or often it's easier if whatever the x squared is, you make it positive. So in this case, I would, as a personal preference, move everything over to the left-hand side so that my inequality looks like this. So I added 3x squared to both sides. I subtracted 3 to both sides. I made the 0 on the right-hand side. Here's my quadratic equality. Now I'm going to find my critical points. And I find my critical points by making it equal to 0. I don't know. I'm not sure if it factors or not, but because we're supposed to learn how to practice factoring, I'll try. So 3x squared, super easy. The only option would be 3x and x. But now the last 3, because I've already written the 3x and x, can you see that there's 2 options? It's different. I'm going to write it in green here. I'm going to erase it later. It could either be 3 and 1 or 1 and 3. And this is where I would not write those down, but I'd think about them in my head. Which one, if I use outside and inside, can give me 8? Or do none of them work? The second one. Because if I use, here, I'll circle it first. If I use the second one, can you see that the outside makes 9x and the inside 1x? Okay. Now I wrote that down just so that you guys would have a visual. In factoring, that's something that generally, we just do that in our head. We're like, okay, it's either 1 and 3 or 3 and 1. I'll try 1 first. Oh, yay, I chose the right one first. Now my outside is 9x, my inside is 1x. If I want negative 8, my outside would have to be negative 9x plus 1x. And again, every time you factor, your very last step should be that you multiply it out in your head just to double check. Does everything match up? Do my first one still give me 3x squared? Do my last one still give me negative 3? And my outside and my inside make negative 8 and 2. So my critical points are x equals 3 and x equals negative 1/3. On my number line, the negative 1/3 would be here, the 3 would be here, and because there's an equal sign, and I strongly encourage you to take this moment to really enjoy filling them in, like relaxing, right? Enjoy them. So nice. So we fill them in because of that equal sign. Now where are the true, false, true? You can either use your critical points or you can use your graph. And in using your graph, the only thing we know about our graph is that we have a y-intercept at 3 and negative 1/3. Those are the only points we would know. Does your graph go up or down? Right? And we would check this here, because that's where it's about the 0. It's a positive 3x squared. That graph looks like this. What are we looking for? Are we looking for where the y values are bigger than 0 or less than 0? We're looking for where they're less than or equal. This section is going to be true. These sections are going to be false. You can see that from your graph. Test points work beautifully as well. Try 0. Here, is minus 3 less than or equal to 0? Yes. You can even use the test point right at the beginning. If I use the test point right at the beginning, I would get 0 less than or equal to negative 3 times negative 1 is 0 less than or equal to 4. Oh, easy. Whoa. Here's a classic. Let me just double check my multiplication skills. -3 times -1. Oh, it's 3. Okay. Whew. Is 0 less than or equal to 3? True as well that way. So your test point will work, it should work, wherever you do it, pending mental math errors, I guess. Okay, now that we found out that that is true, our solution, you could either write your solution like this, -1/3 less than or equal to x less than or equal to 3. We have the equal signs now because those dots are filled in. Or in interval notation, we would write it from -1/3 to 3. Questions to practice on this one? 7 and 11.